Welcome to our project in the domain of data analytics. The project that we have chosen is to predict and visualize heart diseases with an interactive dashboard technology. Our teammates are Soumyah, myself, Ubhanisha, and Heevitha. Now coming to the problem statement, to predict and diagnose a heart disease is one of the biggest challenges that the medical industry will ever face because it's based on the factors, it's evaluated based on the factors like physical examination, symptoms, and signs of the patient. So as per our project, we'll be using data analytics, as I already mentioned earlier, and we'll be creating a dashboard along with the analyzations and visualizations that will help us predict the disease. So we'll be creating a web application to predict the diseases according to the symptoms that will be used as the input and the already predicted results. So when the user gives the input, the application will show us the prediction results, and the algorithm that we have used is random forest and Python as the backend.
Moving on to the proposed solution of our project, we have used classification and regression techniques such as random forest classifier in ML. So it is defined by its use of label dataset to train the algorithms to classify the data or predict the outcomes accurately. So the result of data analysis is to identify the necessary patterns for the prediction of heart disease. So we have got our inputs directly from the user, such as BP level, cholesterol level, maximum heart rate, do they have an exercise angina or not, etc. So these inputs can be tracked by them daily using their smart devices such as smartwatch, smartphone, etc. So the algorithms that can be used for learning relationships, answer complex queries, and also for better accurate results. So this is the technical architecture that we are talking about. We have three modules: user, system, and admin. So the user will give us the their health vital inputs, and the system will pre-process the inputs and divide into training and testing. The training is done based on ML algorithms and the predicted model, and the admin will take care of the web UI and present the result to the user.
So now moving on to the demo. So as you can see here, this is the login and sign up page, and we have provided various validations. For example, invalid password fields and the correct email address. So you can see it shows up the error. And this is for invalid email that we enter a username. So now with the correct email ID and password, so we have created an account. Now we try logging in with an incorrect password, which should throw an error. Now again logging in with the correct password. So now we are logged in and redirected to the dashboard. So this is the dashboard with various features that we have used. So as you can see here, we are entering many values, the sample data here. And once the data is complete, we can click edit and we can see heart disease is present in this sample. So this is the next sample. So we are going to try a different set of data here. And we have also done validations in our fields. For example, age cannot be negative or 0. And also maximum heart rate cannot be a negative value and so on. That kind of validation is being done here. So as you can see here, the result is the heart disease is absent in this patient. And that's it with the demo. And moving on.
So as we have tried out many different algorithms like naive Bayes, random forest, SVM, and XBoost, we have acquired the accuracy of all those algorithms. The highest we have achieved so far is about 81.5% for the random forest. Hence, we have tried out the classification report for that. Precision, recall, FN score, and support have been collected for both the presence and absence of a heart disease. Moving on. The scalability and future scope. So there might be some limitations or requirements which we haven't met. So instead of just predicting the chances of developing a heart disease among the patients, we can also select the proper treatment methods for the patient. We can use a neural network and data mining techniques to acquire them. Eventually, an intelligent system may be developed that can lead to the selection of a proper treatment method for the patient with the heart disease. A lot of work has been already done with making models that can predict whether a patient is likely to develop heart disease or not. There are several treatment methods for a patient once diagnosed with a particular form of heart disease. Hence, we are trying that. Thank you.
Thank you.